everyone. I hope you're all doing well. I want to thank Luka Jacobowitz, a type level member, for being on the show today. I hope you guys enjoy it as much as I did. We'll jump right into the show. We've talked a little bit about monoids, the talk that you gave. Do you want to kind of explain the premise behind it?
Yeah. This was a talk I came up with when I realized or more profoundly got a grasp of how many things can be modeled as like not specifically monoids, but like structures that resemble monoids. And I just realized, like, wow, okay, this is really cool. And once you see the patterns, you start to see them everywhere. Like in everything you do, you start to see monoids, kind of. And that's why I was like, okay, this is going to be a talk about monoids and monoids and monoids. And I wanted to make it like practically applicable to a lot of different things, but also give like an overview of what kind of value you get from this perspective of like abstract algebra, things through that kind of lens. And yeah, I think that's pretty much the premise. I think, yeah. And yeah.
Do you want to start off like with talking about what monoids are, at least, and then maybe some examples?
That is a great idea. Yeah. So a monoid is an algebraic structure, and it's defined by two sort of operations, or and the first one is what is called combine in cats, and basically it's a binary operation that takes two things and somehow out of those two produces one. And this could be pretty much anything. It just has to follow the single law that it must be associative. So if you have A combined with B, then combined with C, it has to be the same as A combined with the combination of B and C. So that's associativity. And that's kind of like at the heart of this talk, more or less. Associativity is really, really, really powerful, and it allows us to do a lot of neat things. And the other operation that defines monoids is the identity. And so if you have some type A, its identity will be some value that when applied, when combined with anything else, will always produce that anything else. That was not the greatest phrasing, but basically you can say A combined with the identity is A, and that relationship is commutative, which means that A combined with the identity is A, but also the identity combined with A is A. Yeah, but monoids themselves are not necessarily commutative. Yeah, and so there are a lot of examples. So, for example, the simplest thing I can think of is integer addition, where if you combine two integers, you get a new one, and that is associative, as probably we've all learned in like fourth grade. And the identity for addition is 0. So if you add 0 to something, that will always remain the same thing. And another one for numbers is multiplication, where if you multiply something, that is associative. But also, if you multiply something by 1, the number remains the same, right? But there's dozens of other monoids that are like found in almost anything. So like string concatenation, list concatenation, set merging or map merging, even something which goes a little bit against the kind of intuition a lot of people have at first, which is that you're combining two things, but taking the maximum out of two numbers or out of two values, any kind, is also an example of a monoid if it is if it has a bound, right? So taking the maximum is also associative, and if it has some kind of bound, that will be the identity. And you can do a lot of these things. And the cool thing about cats that I go through in the talk is that it has a lot of these really nice combinators. So, for example, if you have a function returning some type B, and that B has itself a monoid instance, then the function itself also becomes a monoid. And we have these kinds of things all throughout cats. And like once you see the patterns, as I said before, you can pretty much turn anything into a monoid. Yeah.
So you kind of go on after talking about monoids for a bit, and this pattern that you kind of see everywhere, as you're kind of saying, you talk about intersection union types. Can you kind of talk about those?
Yeah, sure. So intersection union types are new types found in Dotty, Scala 3. And it is very interesting to me because what we have in Scala 2 right now, we don't have intersection union types, but we have something kind of similar, and those are sum and product types. So basically all of our ADTs or case classes or sealed traits, they form sum and product types. And a subtype is just something that is that you can use, like where it's either the one side or the other side. So like the either type, but also like option is a sum type. And product types are just like something like a tuple where you have multiple types. And they by themselves are also monoids, but kind of like at the type level. So, and this is a bit complex. I recommend, if you really want to know about this, to check out the talk because it has more graphical detail, and you can actually look at what I'm doing and what exactly how I'm explaining things. And I think it's a lot easier to actually look at something. But basically, if you take the sum type of two types, that becomes a new type. And so if you have type A and type B, either A or B is this new type, and that kind of is like the combination function of a monoid. And then you also have an identity for either, which is the type nothing. So, for example, either A or nothing, because nothing doesn't have any value, is always going to be the same as the type A. And the same for tuple types, where you can where unit is the identity. And so, for example, a tuple of type A and unit is basically structurally the same as just type A. We would call these isomorphic, and so they're equal, like up to isomorphism. It was what mathematicians would say, which I am not one of. But yeah, so those are sum and product types. And in Dotty, we have intersection union types, and they're kind of similar in some ways. So, for example, the sum types I was talking about, some people also call them disjoint union types. And the main difference between sum types and union types is that they're kind of like, some people also call them tag unions. So, for example, if you have an either of int and int, you can still discriminate between if that either is left or right. Whereas if you have the union types found in Scala 3, if you have int pipe int, which is int union int, there is no way to know which side there is, and that actually comes to the crux of union types, is that they're not just monoids, but they're also semilattices. And semilattices are just like monoids, but they have two other properties that they need to fulfill, and that is first commutativity. And so if you combine something, if you combine A and B, it has to be the same as combining B and A. So the order, you can interchange the order. That's commutativity. And the other is idempotence or idempotence. I really don't know how to pronounce that, but it basically means that if you combine something with itself, it stays itself, right? So, for example, in a union type I just talked about, int union int is actually the exact same thing as just saying int, because you can't know if it's like left or right side. So they're by all means the same. And the compiler actually treats them the same, which is pretty interesting, because when I talked about sum and product types earlier, it was more about like isomorphism, and that's like you have to think like in terms of the structure of Scala data, right? But with intersection union types, these algebraic laws actually hold and can be proven by the compiler, right? So you can say int union int equals colon equals int, and the compiler will say, yeah, this compiles, I can find this. And that's pretty cool. So yeah, union and intersection types are both examples of semi-lattices, and at the type level. And at the same time, something that I was talking about earlier, like the max or the min functions or operators, are also examples of semi-lattices, because the maximum of 3 and 6 is the same as the maximum of 6 and 3, and the maximum of 3 and 3 is still 3. So you have associativity, commutativity, and idempotence. And I think what's really, really interesting about these new types in Scala is that a lot of the abstractions that we have in cats right now are built on things like product and sum types. And once we get these new intersection union types, there might be a lot of really new abstractions that no one has really found before. Because I don't think there's any language out there that has higher kind of types and these first class union and intersection types. So we're like kind of entering an uncharted territory in terms of what cool new things we might find. If you look like back into like 10 or 15 years ago, I'm not sure when exactly the abstraction of the applicative was found, but it's like fairly recent. I want to say like 2005 or something like that. And that's something a lot of us use every day, and it's profoundly helpful thinking in terms of like applicative actions and stuff like that. So yeah, I'm excited. I think there's a lot of cool things that we've yet to discover in a like in a like programmer's context. Probably a lot of it somewhere exists in like some math book written I don't know how long ago, but yeah, we live, I think, in exciting times in terms of Scala. So yeah.
So with intersection union types being in Dotty, are there new abstractions in cats that you're kind of thinking of? Or would those be something that's possible then? Or would the regular language also change? Like, so option, for example?
Right. So I think the regular language does definitely change as well. Like there's a lot of things that are improved immediately just by them being there, like type inference. Because I think like the lobbing has changed. And but in particular for cats, because that's like my main interest, is like what can we come up with? And in the talk, I kind of came up with something like that I just played around with for a couple of like hours or something. I just tried to come up with something, and I already came up with something that was like, to me at least, really interesting. It's definitely nothing on the level of like applicatives or monads, which is something else entirely. But yeah, like who knows? Who knows what will happen? Who knows what people will find? I think, yeah, like people have been claiming to know what kind of like abstractions we deal with for such a long time. Like, oh, this is all we need, and it's never going to get better than this. But a lot of the times we do find new things, and we do find new ways to make programming easier for everyone. Or yeah.
So with the kind of implementation of all of this, all these new abilities on the type system, how are these going to come into play for just everyday Scala developers?
Yeah, that is a great question. The truth of the matter is I don't really know. I mean, I haven't had like a lot of exposure to it. I've played around with it. You can set up a Dotty project really easy nowadays. Or nowadays, I mean, this was like last summer. So I assume it's gotten even better. But yeah, I can think of a lot of things that can be improved by using union types, to some degree, maybe intersection types. But for example, you could type things where you no longer have to choose between a list or a non-empty list by using a union type, where you basically say, hey, what is the type of the last element? And if it's like nothing, that means you don't have anything, and it might be potentially an empty list. But if you choose like A, then you might have a non-empty list that has at least one element of A. So there's lots of like little things like API improvements, like, but I don't know. There might be some really big things, but who's to say, right? I don't know.
Yeah, from my own experience so far, it seems like type inference is the biggest thing that I've gotten out of it.
Yeah. I think that's already huge. So like type inference is really, really nice when it works, and when it doesn't work, you get weird errors, and it's frustrating. So especially like, I don't know, when I talk to people new to the language, a lot of these errors are really, I don't want to say cryptic, but are hard to understand. And I only understand them because I've had so much experience with them. It's like, oh, you just need to add like a type annotation here, and then it just works. But it's hard to figure out sometimes. And I think Dotty will make a lot of like these little usability fixes or improvements, and that's already immensely valuable, I think.
Yeah, I mean, we're already on the topic of Dotty. What are you excited about?
Well, yeah, union and intersection types. That's definitely exciting to me. I think they're like, as I said, trying to improve the UX, especially in terms of like error message and stuff like that. They've added a lot of neat features like enums. They've added like type classes, kind of, or like some kind of mechanism that can work pretty much like type classes. There's a really neat feature called polymorphic function types. So it's basically a new type where you can have first class polymorphic functions, which is not something you can do in Scala 2 without using like a wrapper. So there's lots of really, really neat things. Yeah, I'm really excited. I hope everything goes well. I don't know if 2020 is realistic, but I hope it works. And I know that a lot of at least from the type level side, a lot of the open source community is already trying to get things cross-built with the newer Dotty releases. So I'm hoping it all goes well, and I would love to be able to actually develop applications in Dotty in like a year. That would be amazing, but we will see.
Yeah, that's a bit of the dream.
Yeah.
Is there anything that's kind of worrying right now to you as an open source developer? Like, is it just kind of getting everything done, or is it the business is moving, or?
So I mean, there is a lot of new stuff, a lot of deprecated stuff. I would probably be more worried if I would actually like actively keep track of all the new changes. But as of right now, I'm not super worried. I hope that like the migration um can be like somehow aided by something like Scala fix, which was I think the idea at first, that a lot of these things could just be fixed automatically. I am not super convinced, but I hope we put a lot more emphasis on the migration path for like if it's really supposed to be released by the end of this year. I think there should be, and this is me kind of like because I haven't really been following super closely. Maybe there is a lot of effort being done right now, but um, I would like to see a lot more of that and more of like, hey, this is how you can cross build your Scala 2 stuff with Dotty, and yeah, I guess for a library like Cats, it's going to have to cross build to some version of Scala 2 probably for the next 2 or 3 years, or maybe not, but probably at least a year and a half to 2 years, which is still very very early for a deprecation cycle of like 2.13. It kind of bums me that I don't get to use all these cool new features in the open source stuff, but if I can still use it in application code, that would be great. Yeah, I mean, I am cautiously optimistic that everything will work out. There's a lot of new stuff, a lot of changes, and I hope everything will work. But every time you have a complex change, there's bound to be some kind of breakage, and we'll see. I'm, like I said, cautiously optimistic. I really hope things go well.
Yeah, totally. I'm excited for the ability to kind of go back to 2012 area of the type system's brand new. What can we do with it now?
Yeah, exactly.
So we've kind of talked about Dotty. We've talked about your talk monoids. We've talked about Cats, open source.
Mm-hmm.
How does type level as a group kind of provide business value? Like, how do you think about that?
I think that is an excellent question. I think like type level as a sort of like loose organization of like different kinds of libraries. I mean, it is very like varied. But for example, I think FS2 is pretty much my favorite library I've ever used. Like everything, every kind of problem you can think of in terms of like. And I work at a data company, so I have to deal with these kinds of things. But you might want to stream data from A to B. You might want to like do some kind of batch processing where you have a large file and you take some file of it, process it, and then do something else. And all of these things can be done with FS2 in like one abstraction, that is FS2 stream. And then the whole ecosystem around it supporting like more specific use cases like HTTP4S for developing HTTP applications, web servers, and clients as well. And like, for example, we started using something like FS2 Circe, which allows us to basically stream JSON, like a new line delimited JSON. And I think the real power of like the type level ecosystem is well, first of all, it's community. Like the Gitter channels they're so active, and people are just generally willing to help. Like when I first started out doing like FP Scala, I remember just like asking all these questions on Gitter and getting these amazingly thorough answers. Like, and this is like free support from an already free product. And it is like almost instant. Like you can ask a question and get a really good answer in like an hour or less. And yeah, and I've made a lot of like friends, I guess, there, people I would consider friends, and have these really, really amazing discussions, both technical and not technical. And second of all, which is more to the heart of actual business value, is that I think a lot of the type level libraries are inherently modular and simple, right? I mean, I think for all of the like things you need to learn to become proficient in pure functional programming, which can have like definitely a learning curve, but once you understand it, like everything becomes sort of simpler because now you've kind of clearly separated the the domain of like side effects and doing things that interact with like the outside world with your pure language core where you can do all kinds of data manipulation and pure things. And that already makes a lot of things a lot simpler because you don't have to like defensively program like, oh, when is this thing going to evaluate its side effects? You don't really know, so you have to like really maintain this defensive stance to programming. And at the same time, pretty much all of the type level libraries, they don't do like super magical, crazy stuff. They just have a simple idea and try to make them as type safe as possible and as pure as possible, and just present them to you as a library, not like as a framework, right? So if you look at something like Spring Boot in the Java world, where you have this massive core and like everything is kind of like a plugin, but if you want to put that together with another kind of massive framework, like I don't know, Apache Spark or something like that, you wind up getting like a lot of weird conflicts between the two because they have like they they basically force you to do every kind of problem solving within on their own terms. And the type level libraries are just that, they're libraries, they're not frameworks to get like to draw like that kind of distinction between libraries and frameworks, and things just kind of fit together. Like the other day I was just like browsing for some library that had a specific use case for me, and it had a dependency on cats, and it provided like a monoid or something like that, and like it just works. It kind of just works out of the box because there's no you don't have to write this glue code to get you out of this box you've created by using these prescriptive like frameworks. That makes sense.
Yeah, I mean, do you think it's because of just the basis of functions compose, and that's what everything's built on?
Right. Well, to some degree, definitely. And I think composability is like, how do we make things compose? And yeah, and I think that is like composition is kind of like inherently modular, and that's what gives all these libraries their sort of superpower.
Mm-hmm.
Yeah.
Outside of programming,
Mm-hmm.
what do you like doing?
So I'm an avid musician. I spent a lot of time like composing. I really like composing. I'm not a great musician in terms of like performing, but I really enjoy the craft of composing like um, different kind of songs. I don't have like a favorite genre, but yeah, music is. If I weren't a programmer, I'd probably try to be a musician, even though that's really tough. But yeah, um, have a guitar, play the piano. I used to play the drums, but now I'm mostly doing like digital composition in Ableton, which is a lot of fun. And I might have a SoundCloud sooner or later, so if any of my tweets go viral, I guess I can plug that.
Hey, there you go.
Yeah.
Do you prefer right now digital then?
I do prefer it for composition because it makes my life a lot easier. Like I can uh I can like make a lick or a riff or whatever, and then I can change the instrument after the fact or change the scale after the fact. And there's just a lot of things you can do if you if you use like this digital MIDI kind of based composition, which of course has the drawback that you need good samples, good sounds, or whatever. But yeah, I mean, I do also like just taking my guitar out and playing and singing. Used to be in a choir for a long time. Um, Always loved singing. It's like this burst of emotion coming out of your body with words and singing. It's a lot of fun. I wouldn't say I prefer digital music to analog music, but in terms of composition, that's just where I found like kind of my sweet spot for now. We'll see.
Awesome. Well, how did you kind of get started in programming?
Oh, that's a great question. I think the very first time I touched on like code was when I was doing like a summer course to learn to play learn to program games. Um, I think it was some sort of C# based like game engine, but I honestly don't. We didn't learn any of the basics of programming, and I didn't touch programming until I think it was my senior year of high school back in Germany. And a friend of mine wanted to develop like an Android app, and I was like, yeah, we should do that. And I remember like Googling how to develop an Android app, and then there was like, well, first you should learn Java, and then you should learn how like mobile systems work, and then you can learn Android, and then you can learn how to develop an Android app. I was like, damn, okay, that sounds like a long thing, but I actually stuck to it. I think I bought a book, or I might have gotten a book from the library on like how Java works, and I really enjoyed it. Like it was this like this sort of different kind of language that you sort of like dabble around it. It's all pretty logical, and yeah, I enjoyed it really a lot. And then once I graduated, I applied to go to a computer science program in Dusseldorf at the university. And yeah, and that's pretty much it. That's how I learned to program. I didn't get into Scala until a couple of years later, but yeah.
Did you get into Scala for a job, or was it for just school, or just?
Actually, that's a great question. I don't really remember exactly how I got into Scala, but I do remember. I'm kind of like an idealist in some sense that I really like to. I was looking for like the perfect language, or the language that had everything I wanted. I remember Groovy had this really cool null coalescing operator, the Elvis operator. I was like, damn, why doesn't Java have this? So I kind of like looked around through different programming languages, and I remember seeing Scala, and I was like, oh, this is kind of cool, especially because I think the guy that created Groovy kind of said Like, oh, if I ever knew what Martin Odersky was doing with Scala, I never would have created Groovy. So I thought that sounded cool. But I remember looking at it, and I remember seeing the type inference, and I was like, oh no, I don't want this. I want strongly typed whatever, because I didn't understand back then that you can like actually infer the type without without losing that information of the actual types. But I think like maybe a couple of months later or something, I I heard a lot like about like a lot of like buzz about functional programming, and so I just looked at like what kind of books are there that can kind of teach functional programming, and I found functional programming in Scala, the Red Book by Runar and Paul. And I remember like just reading the first chapter or something on immutable lists, and I was like, I remember my mind being absolutely blown. Like, wow, you can have this shared structure of a list, and you don't like. I remember thinking like, wait, if you just like copy this, like what happens if you mute? Oh, you don't mutate it. Yeah, I guess. Okay, yeah, yeah. That was really cool. I really enjoyed that. And yeah, I think that's how I got into Scala, just by apparently it being a functional language on the JVM, which is probably a common theme for a lot of Scala developers. But yeah, I was super interested in the FP part and what it could do. Yeah.
Do you have any favorite movies, books, media that you usually consume?
No, I don't have a lot of. I don't watch a lot of movies. I do watch a lot of like Netflix, like series, shows. Um, in terms of books, I really like science fiction, like hard science fiction. Um, like I read The Three Body Problem, which was a really amazing book series, and The Expanse. Um, yeah, I really like these sort of philosophical, whatever that word is, take on like futurism and how crazy it is that our world is like it is, and how much more there is out there. How we just this tiny speck in this gigantic universe, and I think that just breeds a lot of really interesting narratives and philosophical questions that can be handled in books, but also in, I guess, movies and TV shows. Do I have a favorite book? Probably not. I can say that my favorite TV show is something completely different from science fiction, and it's BoJack Horseman. If you've heard of it, it's about
I've
this.
heard of it. I've not seen it
Yeah,
still.
it's basically this cartoon anthropomorphic horse that had I was very famous in the 90s because he was a sitcom actor, and now he's kind of depressed, out of work, not knowing what to do, but he's still like a millionaire. And it kind of shows, I think it's a really great show because it like blends comedy and drama to a degree that I didn't know was possible. And yeah, I recommend that to anyone. That is my favorite show right now, at least. It just finished. The sixth season came out in January, and kind of sad it's over, but it's also something I immensely enjoyed and learned from as well. Yeah.
Awesome. Well, I'm going to actually add that to my list then.
You should. You definitely should.
So, is there anything that you've been learning lately, whether it's a new skill or programming related?
Great question. So, in terms of programming, since I work at like a real estate startup, I've been having to learn a lot about like spatial data and like GeoJSON and stuff like that, and PostGIS, I guess. I've never pronounce a lot of these words. Yeah, and like all of these features, I was really surprised. Like Elasticsearch and Postgres, like they support a lot of these things pretty much out of the box, and yeah, it's been a new challenge for me. But it's also been a pretty nice experience. Like you don't want to plateau and not learn new stuff. I've also been getting more into the DevOps side. We have like a lot of HashiCorp stuff to deploy our services. And that's been pretty interesting too, even though I don't like the templating language. But yeah, that's pretty much what I've been learning recently. I've been trying to learn new stuff, or I've been trying to come up with learning new stuff ever since the quarantine started. And I feel like I should have more time, but right now yeah, I feel like I should have more time, but for some reason I don't, and I haven't actually been able to find something good to learn as of yet, but we'll see.
I mean, if you're like me, I've learned to cook now.
Oh, yeah, well, I've been cooking for myself for the last 3 or 4 years. I don't know, 5 years maybe. So that's something I've always been doing. But actually, yeah, I would like to do it more now too. I tend to, because I'm like, oh, it's lunchtime. I only have an hour. I mean, I guess I could take more time, but it's like, oh, I guess I'll just cook pasta again. But yeah, it's a weird time, like spending all day at home all week. I mean, yeah, it's definitely interesting to see how the world works in a situation such as this.
Yeah, it's definitely not normal.
Yeah, 100%.
Is there a subject that you feel like everyone should know?
Well, define everyone, but I would guess everyone listening should probably look into PureFP. And if you're not, or if you're already into PureFP, look into abstract algebra and type theory. At least if you're like me and you just think you like the mathematical nature of it all. And yeah, I think it's absolutely fascinating. When I first learned Scala, I was still thinking very much in terms of like the Java mindset and how everything is like, oh, this is a statement that does this. But actually, like computer science and programming is inherently mathematical to some degree. And all of these abstractions that are found in cats, even though like I use them on a daily basis to solve very practical real tasks, are all like just some kind of mathematical thing that probably, and this is a weird thought that I've had for a long time, and it goes back to like my liking of science fiction. Is like these things that we have in cats are so universally based on math. I wonder if there are other alien civilizations out there that have come up with the same kind of abstraction. That's how general I think these things are, and they're all based on like some kind of abstract algebra or type theory. I mean, yeah, it's just a funny thought that I had, but I do think if there are aliens out there and they also have figured out like physics and math, there's some degree of probability that they would also figure out what monads are, or what monoids are, or semi-lattices. So, I mean, I think that's pretty cool, but that might just be me.
I really like the idea of math as a language in itself.
Right? Yeah.
So, is there something that you think people should use at all, like tools, or like maybe get you through your day?
So if anyone is not using FS2, definitely use it. As I've said earlier, FS2 is probably the most amazing library I've ever seen or used. What else? I'm really interested in the Unison programming language. I would really love to use it at some point. I guess it's still technically in the public alpha. But I hope to see like some sort of adoption, and with more adoption, obviously comes more support and more things that just work smoothly. I think for those that don't know, Unison is a new language, but also a new programming platform, basically built by the two authors of the Red Book, Functional Programming in Scala, and Arya, whose last name I have forgotten. But yeah, it's basically a pure functional programming language that is inherently distributable, because it basically addresses all of its programming language structures as hashes. So a function can be uniquely identified by its hash. And that gives you a lot of very, very interesting properties. And I would love more people to use that, especially in the longer term, right? In the short term, probably no one will use it in production, but in the next 5 to 10 years, maybe this is going to be the future. In terms of like smaller things that Scala Scala developers could use today, something that I really liked was the cat's retry library, which is a small library that allows you to retry certain I/O actions in a very composable and declarative way, without having to do any recursion or stuff like that. Another thing is Cat's Saga, which allows you to basically have transactions for arbitrary I/O effects. I think those things are really, really cool. There's a lot of things that probably should be used more than they are, but those are, I think, some really good examples. Yeah.
Awesome. Yeah, I haven't heard of Cat's transaction or Cat's Saga yet.
Yeah. I think, it's a pretty recent addition to the ecosystem, but I tried it out and it's pretty cool. I really liked it.
Awesome. Well, I'll check it out. Well, thank you for being on the podcast.
Oh, thanks for inviting me. I've had a blast. It was nice getting to know you, and yeah, thanks for having me.